going to talk about work, energy. So we are going to talk about those three quantities. We're going to talk about work, energy, and the power. So let's start with the energy. And energy, as we all know, is that we require energy to light and even to heat our homes. So energy, we require it to light and to heat our homes. So energy is very useful in lighting and heating our homes, and it's also used in communication systems. So the study of energy is important in enabling different sources of energy to be used in getting work done. So energy is very useful in getting work done. So with that little introduction, then we should also familiarize with ourselves with the sources of energy. So one source of energy, which one? The one which is main is the sun. So we look at the sources of energy, and number one is the sun. We have the sun, we have high dams and waterfalls. There are so many of them. And waterfalls, we have even the nuclear energy. We have the nuclear energy. Those are the few examples of where we can get the energy. So we can get energy from the sun, and that one is the main one. We can also get energy from nuclear energy, and of course high dams and the waterfalls. So those are the few examples of energy. So with that, then we are also supposed to see the forms of energy. Forms of energy. And energy, we say energy can never be destroyed, but it can be converted from one form to another. So form of energy, energy can exist in various forms, and one is the chemical energy. We have also the mechanical energy. We have also the heat energy, even the light energy. There are so many examples of forms of energy. So forms of energy can exist in various forms. We have chemicals can exist in forms of chemical energy, can exist in mechanical energy, heat energy, and light energy. Under mechanical energy, they exist in two forms. We have one called the kinetic energy, which this one is due to motions. This one is due to motions, and usually this one is given in a formula like this: mv squared. mv squared. That is the kinetic energy. It also exists in potential energy. And this one is due to the bodies. This is due to bodies and the rest. So when our body is not moving, then it possesses kinetic energy, and when it is under motion or a body is moving, then it possesses the kinetic energies. So it possesses that kinetic energy. So we have seen forms of energy, and we say forms of energy can exist in various forms. it can exist in chemical form. And in chemical form, example is food or dry cells. We have the mechanical energy, which exists in two forms. We have the kinetic energy and we have the potential energy. And finally, we have heat energy and light energy. And the light energy. So that is the real brief explanations of energy. Energy exists in various forms. We've also seen sources of energy, and one main is the sun. We have also seen the sources. We've seen the forms, and we will say energy is very useful in our homes to provide us with light energy. We can also get from it the heat energy, and it also can also be used in communication. So starting energy is so vital important. So the second other subtopic, before we look at that, then we also say energy is measured in joules. Energy is measured in joules. Energy is measured in joules. It's measured in joules. And when you're talking about energy and the work, then you usually say energy is the capacity to do work. Is the capacity to do work. So energy, you can define energy as the capacity to perform work, and the SI unit is joules. Then another topic is the work, and work according to physics. Works according to physics, or we can say work can only be done when there is some force applied to it, and then that work is used to move an object to some distance. So if there is a force exerted and then it moved some distance, then in physics we say work has been done. So this one is defined as the product of force multiply the product of force and distance. So provided work has been done, work can be said is done when force has been applied to move an object to some distance. And force is measured in newtons. Is measured in newtons. And distance is measured in meters. Measured in meters. So in short, we can say work done is usually the product of force multiplied by distance. And work also is measured in joules. So work done is measured, or the SI unit of measuring work is joules. So force is the product of force and distance. Force and distances. Then another one, second subtopic is the power. And the definitions of this, power is the rate of doing work. So power This one is defined as the rate of doing work. So there is a work done, but now you are factoring in time. So we say, in short, in equation form, we say power is work done divided by the time taken. So it is the rate of doing work. The SI unit is watts. So let's look at one example. And we can say one example can say a motor placed a block of mass 72 kilograms through vertical distance or vertical height of 25 meters in 28 seconds. Swali ya kwanza, calculate the work done. Number 2, determine the useful power supplied by the motor. So there are two questions there. So the first question is to calculate the work done. The second question is to determine the power. So there is a motor here which I'm being told he's used to raise a block of mass of 72 kilograms through a vertical height of 25 meters in 28 seconds. So we are told to determine the work done. So solutions. So number 1, work done, we know as the product of force multiplied by distance. So if your answer is determined, we have been given the mass to be 72 kilograms. We are given the height to be 25 meters. So we are going to change this into newtons by saying 1 kilograms is equals to 10 newtons. So how about 720? So we are going to say 722 divided by that. We are going to get the force to be 720 multiplied by the distance, which is 25, which is 25. Now, you find the product of this, you are going to get 18,000 joules. 18,000 joules. Now, power we are told is equals to work done divided by the time taken. So the work done is 72, is 18,000 joules. So this is 800 joules. The time taken is 28 seconds. 28 seconds, and you are going to get something like 642.86 watts. So that is what we have done, and that is how to do those things. So in our lessons, we have defined some work. That work can be done when you apply some force to move some goods or some objects to some distance. And we also talk about the power. That power is the rate of doing work. And the SI unit is watts. We also talk about energy. that energy is the rate of doing work, and we have highlighted some examples of energy, and we say we get energy from the natural source, which is the sun. We can also get energy from nuclear or high dams and waterfalls. We also talk about the forms of energy, and we say one forms of energy is that energy cannot be destroyed, but can be changed from one form to another. And we say energy exists in forms of chemical, it exists in form of electrical, light, in even heat, etc. And energy can also be converted, as we have said, can be converted from one form to another using the transducer. And we say a transducer is a device which is used to convert energy from one form to another. So, like for example, when we have energy in chemical state, so in chemical state, it can be converted to electrical energy, maybe by a transducer, or we have heat energy converted to electrical energy by use of thermocouples, or we can have the kinetic energy being converted to electrical, and that one is done by a transducer known as the dynamo. We can have electrical energy being converted to kinetic energy, and that one is by the motor. We can have also the solar energy being converted into heat energy by the solar panels. So we've come up with the end of our lesson, and if we have a question, then you are free to ask or send a comment. So please like my channel